Well, hello everybody. So I'm coming at you with some old stuff, a little bit of new stuff. So we're going to go over systems of equations this week. So we'll start with solving a system by graphing, and I'm actually going to use the same exact system for each and just show you each method. So systems by graphing, you've seen that before. We'll do that on Desmos. We'll kind of revisit substitution so you guys can remember what that is. And then I'm going to throw a new method at you, which is a method called elimination, which works in some special cases to make problems really easy to solve. So we're going to start off with a problem that we've done before. It's the carnival or local fair problem. So in this problem, we got Gemma. She's selling tickets at this fair, and she's got some bits of information. So on Saturday, she sells 800 tickets and collects a total of $7,680. And it looks like we got the cost of each type of ticket. So adults are a little bit more expensive to get in. Children under 12 a little bit cheaper. And so what we're trying to do is we're trying to figure out how many children and how many adults attended this fair on Saturday. So what we're going to do is we're going to define our variables to start. So always a good practice so you can refer back to and see what you even solve. So we'll say X is kids, and let's just say number of to be more specific. And then Y, let's define that as adults and number of that attended. So let's see if we can figure out an equation. So my goal here is to create two equations, but let's just start with equation 1. So if I say there are 800 tickets sold and a number of kids and a number of adults, and if they say adults, we can kind of assume that they're saying 12 and above, they're considering an adult. So no one is ageless in this scenario. So if we take the amount of adults, add them to the number of kids, we should get the amount of tickets sold. No one else is being charged a ticket or no one else attended. So I can say from that essentially the number of kids plus the number of adults, Y, should equal the number of tickets sold. So pretty simple equation. So if I look at this equation, like I could not have 870 kids attending. I couldn't have -6 kids attending. So if I were to basically like look at the number of solutions of this equation, they're actually 801 because you could have 0 kids, 800 adults, and you can go through the list. And I'm going to go through, I'm going to bring up Desmos real quick, and I'll kind of just plot it. So X plus Y, you could solve for this and put it into Y equals MX plus B form if you want, but we're just going to go ahead and graph it. So if I look at this, here's like my solution of 0 kids, 800 adults. Here's my solution here of 800 kids, 0 adults, and then we've got all these solutions in between. Anything non-integer doesn't really exist. I could have 650 kids, 150 adults. That would be a solution. Anything along this line, of course, we can't go to the left of this point because we can't have negative kids. We can't go to the right of this point because we can't have negative adults. But in this line, there are 801 solutions. So that doesn't really tell us much. That doesn't tell us how many kids and how many adults because this has 801 different solutions. And if we consider non-integers, not just numbers that fall on regular intervals of the number line, we have infinite. So I've got to work a little further. So what I'm going to do is I'm going to make a second equation because we can also make an equation that relates the ticket cost here to the total money collected. So I could say for every child ticket, I earned $7.50 per the amount of kids that were inside the fair. And then I could add on the $13.50 for every adult, which is the same thing as $13.50 times the amount of adults, and that should give me the total cost of the fair, $7,680. So what I'm going to claim here, and you'll see it when I bring up the graphical version of this, is that there is only one case that satisfies both of these equations. And so if I go back to Desmos here and I plot this second equation, so do a second line. And again, if you're using a graphing calculator, you'd have to put this into y equals mx plus b form, but we got Desmos for us, so we don't need it. Plus 1350, y equals 7,680. So you can see here, this is kind of claiming if you had 34 kids, you need 550 adults, but however, that wouldn't make the same amount of money. The only time you make that money and you get that same ratio of kids is when you have 520 kids and 280 adults. And you go back and check this, that is the only number that adds up to 800. And excuse me, I misspoke here. You could have 52 kids and 540 adults. That would make you the amount of money that you wanted, but as you can see here, if I can get back to that point, 52 plus 540 does not equal your total attendance of 800. So only this point satisfies the attendance requirement, this purple line, and the money requirement, this green line. So graphically, we have found the solution to this. So there is x will equal 520. And let's go back really quick. Y is going to equal 280. And I go back, why did I spend this time defining my variables at the start? And I know exactly what these numbers mean now. So x says at this fair, there were 520 kids. And there are 280 adults. All right, so let's keep that in the back of our head. We're going to look at the other way to solve this. So I've got graphing, I've got my solution down. Let's remember this 520 and 280, and let's solve it using a different method. So we're going to use our substitution, strictly algebraic, and we are going to solve this without the use of a graph at all. So I've written my equations down. I've got equation 1, I've got equation 2, and I very strategically highlighted this variable. Because if we said y is adults, this y is the exact same thing as this y over here. So if I knew what y was in terms of these two terms, I could just substitute it in there. So I'll show you what that looks like. So step 1, we're just going to solve for a variable. So over here, I'll do this kind of slowly. So also keep it color-coded. So we got x plus y, and that is equal to 800. So what I'm going to do now is I'm going to solve for y, because if I solve for y, I can just pop it in right there, and I've got an equation that's only got one variable in it. So what I'm going to do here is, just like we normally do, I'll draw my fence, subtract x from both sides. Can't combine it with 800, so I'll just write it to the side. We've got the equation solved for y. It is y equals 800 minus x. So now what you can see here is I solved for the variable. Let's plug in to the other equation. So I'm just going to go ahead. I know that y is equal to 800 minus x, and that's basically locked. There's no arguing that. We set up our equations correctly, so y equals 800 minus x. It's pretty solid. So where I see this y here, I'm just going to replace it with what I know y to be, 800 minus x. So when I copy down this equation again, I'll get 7.5x plus 1350. But I'm not going to write y here. I'm going to write what I know y to be equal to. So I'm going to take this and I'm going to pop it in for y here. So instead of y, I'm going to write 800 minus x. And you might be asking, why did I do that? But if you look at this equation now, we go through every term. I've got an x term. I've got a constant that's going to distribute out. I've got a constant. I've got another x term, and I've got another constant. There's only one variable here, x and x. That's the only variable. So if there's only one variable, I can solve for it. So now I just got to go through and solve for it. So I'll go through as normal as I would algebraically. So what I'm going to do first, So I'm going to distribute here. And I've got a little calculator to the side. So if you want to check my work, you can pause this video, slow it down as much as you'd like. But I'm going to move a little bit more quickly here because I don't think you guys need a review on calculations. So we've got the 7.5x. That'll come down along for the ride. And I got to do 1350 times 800 and 1350 times negative x. So first, 1350 times 800. If I pop that into my calculator, I get 10,800. And then I've got to do my 1350 times negative x. That one I don't need my calculator for. It's just negative 1350x. And now I just combine like terms. So we could subtract the 10,800 from both sides. Draw a little fence to say we're balancing it. And if I do that, I should get negative 3,120. Put an equal sign here. Those terms go away, so I'm just left with 7.5 minus 13.5x. Those I can just combine. And I believe if I do that, I should get negative 6x. And now we just divide off by that term, and we should get our solution. So negative 6 divided by negative 6 just leaves our x on that side. And on the right-hand side, negative 3,120 divided by 6. You can check my work if you'd like, but that will give you a value of x equals 520. And we go back, well, I can fill in some information. I know, kids, that's 520 is the number. And now I am only, this is where you want to be careful, because time and time again, I see students stop here. They go, well, I've solved this giant equation that was really messy, and that must mean I'm done. But however, I only have half of my solutions. So step 3, plug known value back in to get the other one. So we know what the kids are. We don't know how many adults are. And you might be asking, well, I have 2 equations to choose from, so do I plug it back into equation 1, or do I plug it back into equation 2? Which equation do I choose? So you can be a little strategic here, but either way, it'll yield the exact same result. But you can look at this and say, which equation looks easier to solve? Is it easier to plug in 520 into equation 2 and do 7.5 times 520 and then have to like whittle it back to y? Or is it easier to plug it back into this one? And I think you can all agree with me, this one looks like a much easier equation to work with. So I'm just going to plug x back in to this equation. So I got x plus y equals 800, and I know what x is. It's 520. So I just plug it back in here. 520 plus y equals 800. And I just have one step left to do. I just got to subtract off 520. So subtract off 520. Subtract off 520, and I should get exactly what I got before. 800 minus 520 is equal to 280. So y here, those cancel out. 800 minus 520, that will give you 280. So now we've got the entire thing. So got my number of adults, that's 520. I got my number of kids, it's 520. Got my number of adults, that is 280. And I have solved this via substitution. Again, you just solve for a variable and you substitute it back into your other equation and you whittle it back to a solution. So now I'm going to show you a new method. This method is called elimination. So here, we've got our equation 1 and we've got our equation 2. So the name of the game here is, using the properties of algebra, if the x or y term have the same coefficient, and what I mean by coefficient is, if I look at the x term here, the coefficient is 1, it's just 1x. And if I look at the coefficient over here, it's 7.5. If they have the same coefficient, you can just add and subtract them and do the same thing of getting rid of a variable. So I'll show you how that works. So my goal here, and I can do this any which way I want, but I'm going to choose the variable x. I could have chose the variable y, but it really doesn't matter. So what I'm going to do here is I'm going to take equation 1 and I'm going to try to get it to the same x coefficient as equation 2. So it's 1, I need to get to 7.5, so I'm going to take equation 1 and I'm going to multiply it. I'm going to multiply it through by 7.5. So what that'll look like, on the left-hand side, I'll multiply through by 7.5. On the right-hand side, I'll multiply through by 7.5. So equation 1 becomes, if I distribute this out, it becomes 7.5x plus 7.5y. That's going to be equal to 800 times 7.5, which if we simplify that out, it's just 6,000. So now let me show you what I mean. So equation 1, we've rewritten it. X plus y equals 800 is the exact same equivalent equation as 7.5x plus 7.5y equals 6,000. So step 1, I rewrote equation 1 so that one of these terms has the same coefficient out in front. 7.5, 7.5, they match up. So now I'm going to take equation 1 and I'm going to subtract it off from equation 2. So we're going to take equation 2, we're going to subtract off equation 1. So I'll show you how that works. So first I'm going to write equation 2 up top. Let's do 7.5x plus 13.5y equals 7,680. So there's our equation 2. I just brought it down here. And I'm going to subtract off equation 1. So we'll subtract off x. Oh, excuse me. I want the rewritten one. We'll subtract off 7.5x. And I want to subtract off every term. So I'm just going to distribute the subtraction throughout. Minus 7.5y. And of course, we want to subtract off that 6,000. So I'm subtracting off everything. So we'll see what happens when I do that. So first off, 7.5x minus 7.5x minus 7.5x, those terms wipe each other out. They're gone. And now I just got to do 13.5 minus 7.5. So if we do that, we'll just do that subtraction real quick. 13.5 minus 7.5. We get 6 back, so that's left with 6y. And then over here, we get 7,680 minus 6,000. We'll do that calculation really quick. 7,680. And actually, we can just do that in our head. It's 1,680. And now, all we have to do is just divide off by a variable. And I want to stop and reflect really quick. Why did they call this elimination? So if I made this x term the same here as this x term in equation 2, and I just added and subtracted the equations, which I'm totally allowed to do, then it eliminates one of the variables. So we now look at our equations, we added them together, we subtracted we added the negatives together or subtracted off one of the expressions, and I've eliminated one of the variables. There are no x's here. And so now I just finish up and solve. So I could do that, divide both sides by 6, and we'll check our work really quick just to make sure it's the same thing as previous. We got 1680, divide that by 6, and I'm left with just the same as before, 280. And if y is adults, I've got 280 adults. And now becomes the exact same step as back here. I just plug it back in. So again, I could do this step. 280 is y, so let's just do x plus 280 equals 800. To slow that step down, I just took this equation here. I knew that y was 280, so I just popped it in there for x plus 280 equals 100, or x plus 280 equals 800 to get to that. And now I just finish off and solve. So minus 280, minus 280, and I should get back to that 520 kids, which I wanted. X equals 520. All right, so this is kind of trying some new stuff where we introduce some new topics over these little video lessons. So if you have questions on these, please bring them to the office hours. I'll post a little practice on these, but please come back with questions and we can kind of smooth this out. So let me know how this goes. I will see you guys. I guess if you're watching this Sunday night, I'll see you tomorrow morning. If you guys are watching after that, I'll see you guys on Wednesday. So take care. This is Mr. Merrifield signing off.